So I got everything assembled at this point, and then realized I had left the nuts on the switches that I used as part of the alignment process. So I had to tear it all the way down and take those nuts off and put it back together to this point. And I realized that because the switches weren't all pulling through kind of to the same height. And I really noticed it over here in the power switch. And it was odd, and finally with a flashlight looking behind, I could see I left those nuts on those half dozen or dozen switches. I had put them on an alignment, so I've got them all off now. It's really here just going to be a matter of kind of going through and torquing everything, and probably not being as random about it as I should be. So why put a nut and washer on every switch? You could just do a few of them and that would be enough to hold everything in place. Well, the answer there is by having a nut and washer on every switch, the mechanical stress of actuating the switch is transferred to the metal chassis here and not down to the solder joints on the PCB. It's a reliability thing. So like I say, all the mechanical stress is taken into the metal chassis and away from the solder joints, and for long-term reliability, that is of course what you're going to want. So these are all getting close to having them all with an initial torque on them. These don't need to be super tight, but that does look better. All the switch handles, the threaded parts have come through the same amount of spacing. And I'm not going to ratchet these super tight, but I am going to put just a little bit of torque on each one. And I believe with that sequence we've hit every one of the switches. They feel very solid. Of course, they are mounted up against the metal. They feel nice and solid. So excellent. So that's a really good next step. So the step after this is going to be get the dress panel on and go from there. So to do that, I really need to set the dress panel up. So let's get it back over here on the bench. And it needs to be raised up so that the switches and everything can poke down through it. I want to do it in a way that doesn't bind up on anything. Oh, come on, don't slide around. That should be pretty close. I need the little spacers. Forward a bit. And hopefully now I can take this and just kind of using the bolt holes, try not to drop it even though I just dropped it. So that is in place. These are going to be really fun to get to start. There's not a lot of working room down in there. peek, see what we ended up with. The LED heights are very consistent and look really good. The switches are all poking through the same amount and just a thread or two exposed. I think that's turned out really nice. That's a very nice retrofit to get me to a real front panel. It's interesting, this is a octal front panel, which it is. I'm more used to thinking in hex, but very nice, very happy with that. That's come together really well. So I think with this we can set this part of the build aside. And there's now an S100 card that goes in the machine to interface to this. And I think we'll probably tackle that in the next video. So if you've hung on this long, I appreciate it. And we'll talk soon.